or Alice knowing it. The only time that somebody's going to find out is when Alice gets her statements and see that she's been charged $2,000. Now, whether she's going to remember where she was when she bought the newspaper or lunch, that's a different story. But this is how the relay attack works. So we've demonstrated this to the BBC in February 2007 between two stores in Cambridge. There's a bookstore and a restaurant, and I'm going to show you the video. Now, the videos are a bit corny because they're made for the wide audience, but I think they're important for the context, especially the part about people not getting their money back when fraud does happen because of chip and pin.
Hello, good to see you. We're live from the office where tonight, as you may have seen on the news, Watchdog is asking if Britain's banks are playing fair when someone steals money from your account.
Unless it was your fault, the bank's own rules say that they should give you the money back. But lots of you have told us that that's not always what happens. They could even blame you. And it's all to do with this, your chip and pin card.
Now, when these came in last year, everyone says it couldn't be cracked. Well, wait till you see what we've been able to do on an ordinary high street. That's coming up later.
If someone stole your bank card and used it to withdraw money from your account before you'd had a chance to realise it was gone, you'd presume you're entitled to get your money back, wouldn't you? Imagine if the bank said no. Imagine if they told you it was your fault, that you'd been negligent, that the only way someone could take your money is if you'd given them your PIN number. This is a chip and PIN card. The UK switched them a year ago. They were supposed to make our transactions more secure. The irony is that when things do go wrong, it now looks like we're less protected than we were before.
In the days when proving that you'd authorised a transaction involved producing a piece of paper with your signature on, it was relatively easy for everyone to know whether you'd authorised it or not. The banks have introduced a system with a PIN which simply takes that clear proof away.
In the past, if your signature had been forged, by law the banks had to pay out. But there is no law to cover PIN transactions. The only thing protecting the consumer is the banking code, a voluntary code of practice that all banks are signed up to. The banking code says it's up to the banks to prove that you've been negligent. If they can't, then they have to give you your money back. But that's not what's been happening. Since chip and pin came in, it's up to you to prove that you've done nothing wrong. The reason the banks take such a hard line is because they assume chip and pin is unbreakable. But the banks are wrong. We know of at least one way that chip and pin can be vulnerable. These Cambridge University researchers, Stephen and Saar, are about to show us that they can access chip and pin information from somebody else's card. Here's the victim, one of our team about to pay for his lunch. It's going to prove very expensive. In a bookshop a few doors down the road, Stephen is waiting to hijack his chip and pin details. He'll be using a fake card linked to a computer hidden in this backpack. Stephen has an accomplice. Saar is working in the cafe where he's tampered with the chip and pin machine. Instead of sending information to the bank, card details will be sent wirelessly to the computer in the backpack instead.
We've got a customer.
Ready to go, Saar tips off Stephen in the bookshop, who's in position to make his own purchase. It's more expensive, but he doesn't plan to use his own money. The customer in the cafe keys in his PIN to pay his £5 bill. As he does so, his chip and PIN details are automatically sent to Stephen in the bookshop.
PIN is 8046.
He enters the hijacked PIN to buy his books. It's all gone through. Both the chip and the PIN have been read by the terminal in the bookshop. The victim in the cafe thinks he spent £5. In fact, his card has been charged £50, but he won't be able to prove he didn't spend it. If chip and PIN is not 100% secure, then the bank should not be turning down compensation claims from its customers on the basis that the system cannot be beaten.
It seems that when a customer rejects a transaction, the bank's first response is really quite cursory. It looks to see if the PIN was used, and if it was, it says it must be the customer's fault, without considering any of the other possibilities, and I think that is quite monstrous.
Yeah, monstrous.
Monstrous means really bad, right?
Yeah.
Yeah.
So, Watchdog is a consumer watch program. Almost every country has those, and it generated quite a bit of interest, and especially all the attacks that I'm going to talk about were later used as evidence in court when people get when people dispute the bank's decisions not to give them the money back. So this is the kit that we used. You saw the terminal on the left where basically I took all the internal circuitry from inside and put an FPGA board in to control the keypad, the LCD, and the smart card reader. And then it's just connected to the PC. And we've made it play Tetris just to show that it's completely under our control. The video of that is there's a link there at the bottom. So we have a completely fake terminal. It's a bit old, and but the idea is that cardholders can't know what a real terminal should look like. They're not trained, and they shouldn't be trained to do that. So therefore, any terminal would do. And for the fake card, you see on the top right, what I did was I took a real card and I ground down the epoxy resin around the chip to disconnect the wire bonds until the contact pads are exposed, and soldered thin wires onto those pads from the back, and then pressed them onto the plastic with an iron. So on the front you don't see anything, but in the back it's actually wired to the FPGA board in the center top there. And you can see Stephen's hand there putting the card into the terminal. Now this is okay when you see the wire comes down to the FPGA board in the backpack, but with chip and pin, both the customer are trained to hide the pin entry, and the merchant is supposed to look away. They're not supposed to look at you putting in the pin. So it works out. You don't. The wire works out, even though it won't be that difficult to do a little relay circuit, short distance relay circuit without the wire. So this was just a demonstration. Now the FPGA does some real-time processing of the data, and also translates the EMV or the ISO 7816 to RS-232 that is connected to the laptop, where the software for doing the actual relay happens. So total cost of about $500, off-the-shelf hardware, 2 laptops, and moderate engineering skills. It's not too sophisticated to do. So we've implemented a defense against this as well on an FPGA. This is the only slide on it, but it's described in the paper in great detail. But what it allows is for the terminal, which is called a verifier, to send single-bit challenges and receive single-bit response from the prover, the card. And based on the flight time, the round-trip time, the verifier can put a cap on the maximal distance away that it will expect a prover to be. And again, this was implemented on FPGA, and it's called distance bounding, and we used the protocol that was developed in our group by Gerhard Hanke and Marcus Kuhn. It's questionable whether the banks are going to adopt this. It needs minor modifications to the chip and some more serious modifications to the terminal. But this is one solution against a relay attack. Today, there's nothing to prevent it. So I'm going to move on to counterfeit card fraud. And again, you see the dip around 2004, and now criminals have adapted. One of the things that I forgot to say in the previous graph slide is that EMV is a bulldozer. It moves crime around. It doesn't really eliminate it. So what happened was that attackers, the criminals, couldn't use the cards that they cloned in the UK anymore because the ATMs required the chip. So they just did it in countries that the ATMs don't require a chip. So the banks are trying to claim that there's less fraud in some areas, but overall it's just going up. It just moved crime around, not eliminated it. So again, crime is card fraud or counterfeit fraud is climbing up again.
Question?
Yeah.
Are you sure that it's the chip and not the graphical thing on the card? Because in Germany they claim that it's that they have printed on the card a graphical mark which you can't see with your eyes, where the ATM is using to make sure that the card is not closed.
On the mag stripe, you mean?
No, not on the. They say it's graphical, so I thought.
I don't know about that.
Picture or something like that.
I don't know about that.
Hidden in the printing on the card or something like that.
Well, you'll have to detect it. So maybe ATMs in Germany do detect it, but elsewhere they don't.
Yeah. Right. You can go to France and there you clone cards.
Right. Again, these are figures only for the UK, but we can talk about that. I don't know about what mechanism you're talking about. So the next thing is to see how secure the pin entry devices, those terminals that you put in the card into, how secure are they? And remember I said that the UK issued cards that don't encrypt the pin, and all the magstripe data is going back and forth with each transaction. So if you can get to the I/O line between the card and the CPU and record the data, you'll get everything you need in order to create a fake magnetic strip version of the card and use it in an ATM that doesn't have chip and pin. So we wanted to see if that works. But the pads are certified by various bodies, standard bodies, Visa, Apex, PCI, payment card industry, and evaluated to common criteria. They're actually not common criteria certified, only common criteria evaluated, which is an interesting play on this certification scheme. And Visa, for instance, requires that these pads will require $25,000 per pad to circumvent the security or the tamper-proof mechanisms in it. So that means it's not a one-off investment. You will have to invest $25,000 every time you compromise one of these things. So I got a few of these pin entry devices off of eBay, about $10 each, and tried to see if these do meet in practice the criteria in which they were evaluated for. They're not restricted for sale, and they're the most popular pin entry devices in the UK. I estimate that about 50% of the pin entry device market is shared between these two. The one on the right is being phased out, but the one on the left is still being used. There are millions of them. So this is the Diode, the one on the right. You can see a resistive pad pressing onto a capacitive structure in order to connect a trace that will, once it opens, then that link will break and the tamper detection mechanism will trigger, and the secrets that are stored in the security module will erase essentially the keys that allow it to communicate with the bank. What you don't see there's actually two pads that you can, in parallel to the capacitive structure, that if you drill a hole, you can connect it and then defeat this. It's this one's not very good. This is the Angelica one, and you can see a switch. There is a better picture ahead. It's a switch with a turret that is pressing onto the switch as the pin entry device is closed. And once you open it, again, the tamper detection mechanisms trigger. These are 4 capacitive structures that are being pressed by these pads as the pad is closed. Again, once it's open, these are resistive pads. They press and they close the circuit. Once it's opened, again, the trigger mechanisms erase the keys. This is that switch that is being pressed. It's protected by a wall against drilling from the back. So this is a view from the back, and I'll show you another picture with a compartment that is user accessible. And if you drill through this in order to get to the switch, again, it'll trigger. Now, the entire circuit board has a sensor mesh as one layer, and that's again to prevent drilling from the back to get to the processor. This is the processor module. It's again, it's wrapped, it's gift wrapped with a mesh, a sensor mesh, and potted. This is epoxy resin. It's the plastic cover is removed here. This is where the main processor lives. This is where the tamper detection circuit is, and this is where the keys are stored. And they go away once things trigger. This is the Diode equivalent, and the keypad is on the other side. So the keypad and the sensitive circuitry is potted. What's interesting to note here is that I was able to get such a clear view of the chip is because they put a sticker on it before they potted it. So you can grind it down quite coarsely, and then you get to the sticker and just peel it off, and you can see the information of which processor they're using is quite useful. This is the oscillator here. But all of these mechanisms can be circumvented with a paperclip and a needle. To do what we were after, looking at the I/O line. So here you see the only thing that is really needed is to create a little hole in the plastic. This is the user accessible compartment. This doesn't trigger anything. You open it with a screw and you can close it and nobody will notice. This is a bent paper clip that with some agility you can force it within some tolerance of the plastic and connect it to the I/O line of the card. And you can put a little circuit inside. We've built a circuit. It doesn't quite fit. It's almost fits, but it's off the shelf. But you can create your custom hardware that will fit inside here, will record as many transactions as you want, and nobody will notice because the designers provided you with this nice compartment to put it in. The other thing to note is that I showed you before there is a sensor mesh here to prevent drilling. This is the front side, and this is the back side. So if I drill, I will get the mechanisms triggered. But I'm going to go away from the microphone. Right here and here, I don't have good pictures, but there are 4 holes in the circuit board, and these are used for mounting SIM extension slots. I've never seen them mounted, but actually they're not 4, they're 8. 8 holes for mounting these slots here and here, here, and here. And through those, I was able to insert a clip that clipped onto the I/O line. So they went through all the trouble of creating a sensor mesh throughout the board, yet somebody put holes in it. And I'll talk about the reasons why this happened later. And again, this is the other one, very small hole, stuck a needle through, and it connects to one of these pins. This is a ribbon cable connector, and it'll connect to the I/O. It's very nice because it's nice and flexible. You just plug it in, and you're there. You just hook a wire in there to it, and you get the entire transaction. So we've seen that the tamper protection protects the bank secrets quite well, but they don't protect the cardholder pins and card details almost at all. So again, we showed this to the BBC, or the BBC filmed us do it for real in a shop. And this is a response from Apex, again, the UK banking industry body, and said that this isn't practical. You've done it like they always do. They say that this is only possible in the lab, not on the high street. Yet criminals have been doing this since around 2006, and there was a widely publicized case of an Irish gang going into a supermarket and trying to do almost exactly that. I don't know exactly the details, but similar. They tried to tamper with the pads. So I'm going to show you the video of that. Now, in the UK, there's a guy called Jeremy Paxman, and he's the anchor of the program called Newsnight, and he's known for not letting go of his interviewees until they answer him. And it's quite fun to see him grill the Apex lady. So enjoy it. Where's this control?
Good evening. In a very short space of time, the system of chip and pin, punching in a code number each time you use your credit or debit card, has become ubiquitous. The great advantage, we were told, was that it had such good security protection. How could anyone steal from us if only we knew the numbers which would make our card function? As Susan Watts reports, it seems we were naive. By the way, while they were filming this piece, our cameraman fell victim to the fraudulent withdrawal of £1,000 from his account by someone in Serbia.
That's my desk.
These were once intact pin entry devices, or PEDs, which Stephen and Saar bought on eBay for around £30, giving them free rein to explore the inner workings of each device. This one is made by a company called Angelica and is among the most common of the PEDs in use in UK stores today, in shops including Boots, Asda and the Co-op Group.
We found ways in which we can get into that interface between the card and the processor, and we're able to read the data as it went back and forth.
It sounds simple enough in theory, but these PEDs aren't live. The real test is whether the attack works on an active terminal. Away from their workbench, we provided the Cambridge duo with a live merchant's machine and a real credit card to test out their theory.
Right.
So let's go for a transaction and see if it works.
That's right.
We're not showing you whose account it is, just as we've been careful not to show any potential fraudster, enough that they could carry out this attack. So now we just check to see that you've actually managed to pick it up, yeah?
Yeah.
So the researchers have read off the name of the cardholder, their account number and their PIN.
The attacks that we've shown have demonstrated that it's easy to get the PIN as well as the card data out of the chip and PIN terminal. And this means that simply holding your hand over the terminal is no good. In other words, the customer cannot defend himself or herself, no matter how astute and careful they are. Therefore, surely the banks must take responsibility.
By showing that chip and pin terminals can be easily compromised, the Cambridge team should now have made it harder for banks to blame the customer. There's now enough doubt about chip and pin for the onus to be on the banks themselves to come up with the evidence that it was the customer and not the security of their chip and pin system that was at fault.
Well, with us now is Sandra Quinn of Apex, which is the trade body representing the card issuers and users. How many chip and pin machines are there in Britain?
Over 1 million. We have a lot of pin entry devices, and the important thing to stress from this piece is that we're not talking about a break of the chip and pin security overall.
Well, I think, according to that, we certainly are. How many of these Angelica machines are there?
There's a large amount, but I think the important thing to stress is exactly what the Cambridge team themselves have said. This is a difficult fraud to do and to replicate in a large scale. So
well, they did it by acquiring stuff on eBay.
Absolutely, and you can do this fraud. What we're very careful about saying is we don't deny that this fraud can happen, but as we currently stand, there are more economically viable ways of fraud being undertaken by fraudsters, and that's what our real concern is at the moment.
You have known that this system is vulnerable for a length of time you're not prepared to disclose.
Well, let's clarify. The system is not vulnerable. Chip and pin is extremely
secure. We've just seen it's vulnerable.
It's not 100% guarantee against fraud.
So it is vulnerable?
No, there is no guarantee, 100% guarantee against fraud.
So it's vulnerable, by definition. If there's no 100% guarantee, it's vulnerable.
All fraud, all systems have an inherent level of risk.
Sure.
And what we have done is look at the risks there, undertake a risk assessment and make sure that we protect our customers as much as possible. I think the figures speak for themselves here. As the piece said, card fraud with chip and pin has fallen.
In Britain?
In Britain.
The problem isn't in Britain though, is it? And you know that.
Well, one of the reasons that we're making a very strong case to ask countries around the world to introduce chip and pin to ensure that we're all operating on the same global standard so that we can make sure card holders are being protected properly.
Sandra Quinn, thank you.
Thank you.
Unfortunately, I meant to show a different one that has an extended version. I'm sorry about that.
Can you Google for it?
Yeah, actually, let's see if that works.
Otherwise, people can Google afterwards and see.
It's not linked, but yes, please do. There's it's interesting because I should have looked at it completely, but anyway, there is a part about asking about an enhanced version of the card that they're being rolled out, and she's saying that it's not more secure because of it, and he's giving her a hard time. It's quite entertaining. Anyway, sorry about that. I'm moving on to online fraud, card not present transactions. These are when you do online transactions where you put in the card, you put in the card details into a form, and the card verification value, what we call the CVV, the thing on the back. That's CVV2. CVV1 is on the mag stripe. And we see a spike. This is where the fraud went to. People couldn't do regular fraud anymore, so they went to online fraud. And you see how far it gets, how high it gets. Criminals are using simple techniques such as phishing and keyloggers. So there's been a few ways to try and prevent some of this online fraud. On-screen keyboards, picture passwords. This is where there's a picture appears. I don't know if you've used those things. I know Bank of America uses it. You'll choose one picture, and if it doesn't appear, you know that you're being phished. If it does, then you have a better guarantee. Though a real-time attack will defeat that. And then there's one-time passwords and ITAN that they use in Germany and other places like Brazil. So ITAN, for example, gives you a serial number. You have this form, paper form in your hand, and it'll ask you for a number. It'll ask you for the code that corresponds to a serial number. You put that in, and then it's another form of authenticating or being more assured that you possess something else, not just the card details. But this could be defeated if a phishing website starts asking you for 10 of those, or in other places making you enter these 10s, and then going and hoping that that they'll get the 10, get the right number. Now, also, if this is done in real time, then the 10 is defeated. So malware can help fraudsters against these types of attack. Man in the middle, or a combination. What we're starting to see more is man in the browser. This is where you get. Well, I'll describe it in a bit later, but you understand. Once you have something in your browser, once you have malware, these static mechanisms for authentication just fail. So this is the man in the browser attack, where the man in your browser sits between what is displayed to you and the connection with the bank, and it'll show you everything until it asks for a code, and you'll put in the code, but the evil man will change the target account number, and transfer the money out. Now, this is possible because the code isn't tied to the transaction. There's no what we call transaction authentication. And it can change the destinations and the amount in real time. And any code will work. Not any code, but any code at that particular time will work. And if it's clever enough, it can change the statement, your online banking statement, such that you won't be able to detect how much money actually went out for a while. German banks are really on top of these things, and in order to prevent that, in order to make it more difficult, they put a Captcha on the TAN request. So now it requires a person to actually look at it in real time as they're doing the attack. So it makes it more difficult and probably moves the attack to the phishers to use other banks or customers of other banks. So in the UK, they decided to deploy these disconnected card readers, and it's called the Chip Authentication Program, CAP, and it's a protocol that the specification of which is secret. But it's based on EMV, and which is open. So we took it apart. We reverse engineered everything that this thing does with the kit that we had from previous attacks or experiments. And I'm going to talk about some of the issues that we identified. The way it works is that you start a session, online banking session, and you enter the card into the card reader, and you enter the PIN, and the reader verifies the PIN, and it'll tell you if it's correct or not. If it's not, it won't continue. It will only continue if the PIN was correct. Then the customer enters the transaction details. That depends between banks and the mode. The card calculates a MAC over the counter on the card, the transaction, or a counter on the card that is monotonically increasing, such that it's a nonce. And the information that is entered by a customer, and some information, depending on the mode, that is displayed on the web form, and also the result of the PIN comparison goes into that MAC. And the reader displays a decimal value that is made of some bits of the counter. So on the banking end, you can synchronize the counter. So it's a hint to the backend system to know what the state of your counter is, because sometimes it'll get out of sync. And some bits of the Mac. There is a mask that is applied, and we know them. We figured out the Mac. It's in the paper here. The mask. So there are 3 modes that the CAP uses: identify, respond, and sign. Identify doesn't require anything else from the user except entering the PIN, just the code that just appears. There is a respond with a challenge. It's called the number. And a sign, which is the destination account number, ref, and amount. Now you see, these are not very descriptive, so criminals can use this to their advantage and try to get the customers to put in data in the wrong order or do various things. It's just bad for usability and bad for security, that ambiguity. So 2 banks we looked at, Barclays. They ask for identify for login, and sign to do a transaction. NatWest, on the other hand, doesn't require the CAP for login, but needs a respond with the 4 random digits and last 4 digits of the bank account, the target bank account. The difference between these is confusing. I bank with NatWest, and when I log in, sometimes I get a warning to tell me that I should never use the CAP for login. So apparently, someone was. There are phishing attacks that pretend to be a NatWest bank site that asks for codes as a login. So they're warning people against that. But if they bank with the 2 banks, they can be confused, because Barclays does require CAP codes for login. The type of the mode isn't part of the MAC, which can be problematic because a sign response with an empty or 0 amount is also a valid response, which could also be used by criminals. And the account field is overloaded, and being also both a nonce in one mode and a destination account number in another. So that could create problems. So a practical attack on using CAP, because some banks like Barclays don't require a nonce as part of the MAC generation. We can collect codes and then use them later, as long as the cardholder didn't log on to their online banking. Those codes will be left valid. So we can use our fake terminal at a shop, and when the cardholder supposedly pays for it, we're just capturing CAP codes, because we reverse engineered what the CAP does. So it's just code running on the PC. So we generate all these codes, and then either in real time, or we SMS the codes, or email it to somebody else, or do it ourselves. We can now log into the bank, to the online account. We do need some more information. We need the login name, so that could be phished by calling the person and saying, oh, hi, I'm from the bank security. You just paid at this and that, because at this place we know, and to show that we know what we're talking about, and we're asking them for that login name, which isn't secret. The banks tell you that it isn't. So we've actually done this again for the BBC, and it'll show in a couple of weeks. It works quite well. The CAP can also change how criminals do their street crime, because now they have a device that they can verify that you've given them the right PIN at mugging. Before, they had to drag you to an ATM and try to get you to enter the right PIN. Now they can do it in a street corner. And And we know of 2 cases where people have been tortured and killed for their bank details. I don't know of any cases of people using the cap, but it can definitely change. Now, it could also change that people won't be tortured like that. I don't know, but it definitely changes and how street crime can be performed, because it was always possible to construct one of these devices that will verify the PIN. But this was a design mistake. They could have made the reader continue regardless of whether the PIN was correct or not, and just generate a code every time. If you enter the PIN wrong, the code will be incorrect. So what? But since they stop when the PIN is incorrect, they created this opportunity for criminals to use this device in the streets. The supply chains can also be infiltrated. We've heard of cases about a year ago where there's a little GSM module inserted into PIN entry devices at manufacture time, and it collected card details and sent them through SMS to somewhere in Pakistan. And the only way they detected it is by some guard at a supermarket had some interference with his phone, and somehow they figured out that something is wrong, and then they had to go through to all the supermarkets and all the places that use these PIN entry devices. I don't think it was that one, but and had to weigh them, because there'll be with the GSM module they're 100 grams more, they're 100 grams heavier, because they can't open it. Remember, if they open it, they go away. They become useless. So this is a supply chain attack, and you could do it with cap as well. The banks tell you that you can use any old cap because there's nothing in it that is personal to you. So one attack is that I could tamper with one of those things and sell it on eBay, and then you will use it for a while. It'll ask you for a whole bunch of details, like your login name and other things that aren't really required, but you don't know. And then it'll stop working, and I'll say, okay, I'll refund you the money and send it back to me. And then I get it back, and I can harvest those details. Now, industrializing that type of attack may be hard, but if you're targeting someone specific, that's entirely plausible. So we reverse engineered it so we can do a software version of the cap, and some are already available online. There's a link from our in our paper, I believe. And why is that useful? A software version of the cap means that you can have a card reader and have the card connected to it, and you will be able to pull or get codes from afar. You don't have to carry that cap with you. Or if you have multiple cards and you just can't be bothered, you want to press a button and generate a whole bunch of codes, then that would be useful. But the problem is that the cap was meant to be a separate device to your PC that could have malware on it. Now a software cap can go back into the PC and be affected by malware again, defeating the entire purpose. So I think that chip and pin is a very good example, or a very good test case or a case study for failures of design, certification, regulation, and the incentive structure of the entire system, of a widely deployed security system. So it kind of ties into the theme of this workshop, and also many of while I was listening to all the talks that we've had the last couple of days, I identified a lot of similarities in the things that are happening with chip and pin. So we can draw quite a few interesting conclusions from it, but it really is a large deployed security system, and we should consider that. So some of the lessons, the protocol designers made unrealistic assumptions of tamper resistance. they assumed that the interface between the card and the main CPU will be protected, but that's clearly false. It didn't. That information didn't really register with the person who designed it and put a hole in the sensor mesh. The specification is thousands of pages long, and you can't communicate all the things that are specified there to all the people who are involved in deploying this system and designing it, or designing the elements of it. So, so that's why we see some of these issues. Also, managing the evolution of a system like this, like chip and pin, should be defined from the beginning. We see time and again how one system is used in ways that it wasn't designed to be used as time goes on, and we see this with chip and pin. We used to only enter pins at ATMs. Now we enter them at tills, and now we enter them with caps. The tokens are overloaded, and that's never good for security, because now criminals have more ways of getting it, and they're suggesting more uses of chip and pin, like in the UK to use it for identity. And as part of identity cards, and don't use a system that was meant for one thing for other things. Things will break as you patch things up. The entire banking system is a huge patchwork of things that were designed 50 years ago and with mainframes, and then for backwards compatibility, a whole bunch of vulnerability arise. Some of them are issues that I showed today. So another thing to consider is the system usable? It just came out last week that a survey that 8 million people in the UK share their pins, which is a large number. There's only 60 million people in the UK, and some people can't remember their pins, which is quite reasonable. Are they to blame for this, or do the banks deploy a system that is just unreasonable to expect people to follow the rules? And the rules are: you should never write down the PIN, even in an obfuscated form. If you ever tell the banks after fraud has been committed on your account that you've written your PIN in any kind of way, even on your cell phone as part of a phone number, they will not give you your money back, or they'll try not to give you money back because they will claim that you've violated the terms and conditions. So that's something to consider. But mostly, we have a problem of poor incentive structure in the UK, where and in the certification process, where banks can now dump the liability of fraud onto merchants and cardholders, whereas before with signature they had protection by law. So if I signed a receipt, I was actually protected by law. And now with chip and PIN, there is a voluntary code of practice that the banks drafted themselves in order to, and again, it's voluntary, and they wrote it. And what it allows them is in the same document, it's very carefully crafted. In the same document, they can, on the one hand, they claim that you're protected against crime for up to, so you will only pay up to £50. But on the other hand, it'll say that you are liable if you haven't taken reasonable care. That is the technical term that they use. So reasonable care can be interpreted in many ways. And that applies also to online banking. If they can show that you haven't taken reasonable care by patching up your computer and using the latest antivirus, you won't get your money back if you've been defrauded, if you're a victim of online fraud. And with the PIN entry devices, the bank set the standards for the security. Their keys are protected, but we saw that the card data isn't. And the customers have little to say about the security systems that they use for online and in shops. So there's no competition. The banks don't compete on security in general. They present a common front. I'm gonna skip that. Well, again, last week, a survey from this Consumer Watch organization, which came out and said that with a service that 1 in 5 cardholders do not get their money back after fraud, which is quite a large number. There are other issues that I won't get into. Well, I'll briefly mention because I'm already stressing the point too much. But the banks are reluctant to provide victims the evidence that they use in order to determine that they've been fraudulent. For instance, one of their rules is that you need to destroy the card after fraud. And to me, that seems almost exactly like cremating a body after a murder before an autopsy. But that is procedure. Again, and another thing, the cardholders are told not to go. Well, by regulation, you have to go to the banks first before you go to the bank in order to complain, and the banks decide what to do with you or with your case. I'll skip this thing, and this is the way forward. Some of the things that I mentioned: online banking, do transaction authentication, and not optimize away a lot of the things that we see in CAP. It will require higher bandwidth or connected devices and more input from the user. There are devices that already do this. I think they're deployed in Germany. For counterfeit cards, use PIN encryption, the dynamic data authentication, ICVV. That's something that was proposed in 2002 by MasterCard to not have the same 3-digit number that is on the mag stripe, the same as the one that is stored on the card. And that supposedly is ICVV is in cards issued in the UK from 2008, but we tested a few early 2008, and we saw that ICVV wasn't actually there. I hope it's there now, and we've heard that PIN encryption is starting to be deployed because the prices of these cards have gone down. I'd like to see some more protection by law, like in the U.S. In the U.S., if the banks can't prove within a few days that you've been negligent, you get your money back. Whereas in the UK, we've discussed what the issues are, and more effective customer protection agencies like the Financial Ombudsman is not really effective in protecting customers. The design process, probably good for many other systems, have a clear communication of security goals in a concise way, such that all the people that are involved in the design know what they're supposed to be doing. And in the certification area, create a liability structure to prevent security failures, where you hire the certification body that will approve your product rather than the one that will find security issues in it. So hostile evaluation, and we can also provide prizes for exploits that would be paid by the authorities that certify the evaluation labs. So these are outlined at the end of our paper on this. So this is the end of the talk. You can find a lot of our work on the blog, our group's blog, and everything I talked about is here and on this link, including the videos and FAQs and other discussions. That's it.
All right, so thank you very much, Saar. I have a couple of questions for you. And first of all, in the beginning you said there was maybe different implementation. It could be different implementations in different countries. And you mentioned something about some people using asymmetrical cryptography for this. Do you know how is the UK doing it to other countries? Then what other countries are doing other things? Do you know what they're doing here, for instance?
No, I don't. There are essentially two encryption mechanisms, two encryption ways to encrypt or to create MACs, and well, there is a static data authentication that does only symmetric cryptography, and that's used for generating the MAC, but it can't encrypt because the terminal, the pin entry device, and the card do not share a key, right? And then there is dynamic data authentication, where the card is capable of doing RSA, asymmetric cryptography, and there's a key, the public key is being sent to the terminal, and then they can encrypt the pin between them. And I do not know what type of cards other countries are issuing. But when chip and pin came out, the cost of the DDA card, the asymmetric cryptography capable card, was double than the symmetric one. It was about $2 to $1. So they decided to go with that. But now they're about the same price, I understand. So they're starting to deploy that.
But the cards do fallback to symmetrical crypto. I mean, if you have the card, does the readers fall back automatically?
I think that most pin entry devices today are built to handle a wide array of protocol options. So I think all of them are capable of doing it. It depends on how on some of the options and how it's implemented. You may be able to sometimes fool the terminal into thinking that you're not capable of doing pin encryption by flipping a couple of bits, and then have it, and then capture the pin, cancel the transaction, and then do a real transaction. But then you have the pin already. So because the transaction will fail if you flip those bits, and then but then you can just do another one, right? And that will go through, and you got the data that you wanted.
True, and these relay attacks, there would be really no way of protecting yourself against these. I mean, there are wireless terminals today. There will be delays and stuff like that.
You as a cardholder, there's no way. And remember, the interesting part about the relay attack is that it can work on any type of card.
Yeah.
Even if there is encryption or anything, you don't need to understand the protocol itself in order to execute a relay attack. That's the beauty of it, and it's so simple. So no, there's very little, in fact, that the cardholder can do except check their statements regularly to see if there's been unauthorized transactions on their account, and notify the banks immediately, their bank immediately.
Yeah. All right. The chip and pin cards, were they ever designed to add any security for the end customer, for us, or was it more for the merchants and more for the banks? Or I mean, was it intended to actually become better?
No, not as far as I know. What do you mean by better?
I mean, it still has the same type of problems that magstripe cards has, obviously. Fraud, I mean, we still are obliged to pay for the loss of the banks and stuff like that. It's not like we have more protection.
Right. In some ways, you have less protection. I'm talking about the UK. You have less protection because you're not really protected by law as you were with the signature. But remember, when they deployed the chip and pin in the UK, they kept the magstripe in the back, so you could still do the same skimming attacks as you could before. There was nothing to prevent that. The reasons why they do that is because they didn't want to prevent you from using the card abroad. But I would have preferred to get a card that I can only use in the UK that didn't have the magstripe, and I didn't have to worry about it.
You opt out of the magstripe, but
Yeah.
still, as long as there's a magstripe reader somewhere and the
Right.
numbers are the same, it doesn't matter if you opt out of it.
Yeah, and some merchants, I haven't seen this in a while, but sometimes they'll just take the card from you, they'll swipe it someplace and then put it in the chip and pin machine, and that's just bad example, because people get used to people skimming skimming their cards. The merchant's not supposed to take the card from you.
Exactly, and it's still the same information on the magstripe. So as long as there's a magstripe reader somewhere,
Yeah.
even if you don't have it,
Yeah,
somebody else has it, they can use it.
yeah.
All right. Questions? Ilya?
Yeah, a non-technical question. How should I phrase it? I sense a difference. I'm not sure about it, but hear me out. A difference in attitude between British banks and their customers, and from what I've read from Swedish media, Swedish banks and the Swedish customers. So the profit margins for credit card transactions for Swedish banks is huge. It's a great source of incomes for the Swedish banks. Do you know? Are you aware of how it is in the UK? Like hunting down the customers, like in your example here, I saw one of the slides saying that 20% of the customers get denied compensation when exposed to fraud. Wouldn't it be easier for the British banks just to pay out the money and try to stick to the possible high profit margins?
I don't know the answer to your specific question, but I do know that sometimes the bank will go to great lengths to fight fraud cases that they don't believe that are genuine. So there's first-party fraud where you, the cardholder, is getting money out of the account and then saying, "I've been defrauded, I want the money back," right? This is what they're trying to fight. But they'll spend a lot of money on lawyers in order to fight these cases where somebody's asking for £500 back, and they'll spend I don't know how much money just on lawyers. But it doesn't make sense to us, but it may make sense to them because they don't want to create a precedent that will erode the image that they're trying to portray with the security of chip and pin.
Question about magstripe again. You said the cards that didn't have magstripes on them, so they couldn't be used for ATMs abroad or whatever. Would the chip in those cards still have the track-to data on it?
Yeah.
So basically, those are just as vulnerable to cloning onto a blank magstripe card.
Yes, this is what I was talking about with the iCVV, which sometimes they call it CVV3. It's so when chip and pin came out, it was exactly the same data on the chip and on the magstripe. But now the new cards are supposed to have the difference in those 3 digits, such that if you do the attack on the pin entry device attack that I described, you won't get the correct data. Now, whether that three digits are being verified in an ATM in Thailand, I don't know. If it goes all the way back to the issuing bank in order to verify.
Well, another question and follow-up to that. In offline transactions, it couldn't be verified, right?
Right, exactly. Good point. I didn't mention this, but there are what's called yes cards, where because the certificate is static, there is a certificate there that the pin entry device is verifying, and it could be replayed. Right, be programmed, and then the card will always say that the pin was correct and provide a MAC that is incorrect. But since it's an offline transaction, there's no way for the merchant to verify that it's correct because he doesn't have the key. The key is with the banks, and they only do it once a day, where they send all the MACs for verification. So yeah, online transactions, and I think about a year ago they said that there about 10% of transactions are offline in the UK. You can notice that sometimes, how fast the transaction happens. You can tell, like like in supermarkets, for instance, sometimes it's very quick, and sometimes it takes a couple of seconds.
I think in Sweden, very, very few transactions are offline. I would think it would only be in case of failure with a back-end communication system where you would get a fallback to an offline transaction.
Right.
So, but like you said, in Thailand is a whole nother different deal. They might even have the old scratch, you know,
Yeah.
carbon paper deals. I don't know.
Yeah, each merchant, depending on how big they are, they negotiate deals with the acquiring bank. Yes, that to put a threshold on the transaction amount and some other conditions, whether it can go offline if something happens. So some are set to 0, some are set to £50 or euro or whatever.
There are also built-in stuff in the chips that the issuing bank can set policies on what the card's allowed to be used for. Have you seen any improvement in setting those policies a bit tighter, or are they still pretty lax?
I don't know. One of the things that one of these policies is how many transactions will the card do offline. So it'll say I'm willing to do 3 transactions or £100, whatever comes first, and then it'll refuse to authorize a transaction. But I don't know the details of exactly what those conditions are.
I'm sorry I'm taking up so much of the question and answer time, but if you get a smart card reader, plug it into Adam Laurie's software that he showed off earlier, you can actually dump out those policies and get them in clear text so that you can see what your issuing bank has set for policies for your card, what it's allowed to do and what it isn't allowed to do. At least it should be able to do that because I sent him diffs for it, but I don't know if it's in there yet.
More questions?
What's your opinion on technologies like verified by Visa and verified by MasterCard?
That it's verified by Visa and 3D Secure. That's the MasterCard version. Well, the specs are secret, but they have some usability issues. We're actually looking into that. Again, it's a minor improvement. What these schemes do is, when you do an online transaction, it'll ask you for another PIN or another password or 3 digits from a password that you set and you signed on to. One of the problems with that is that you need to agree to use that system, and if you read the agreement, there are some things there that you'll find that give you less protection in case of fraud. That's one of the issues. I don't have specific examples, but I'm still working on it. There are other usability issues. It's just another password.
A couple of banks in Sweden have rolled out CAP for login for internet banking and for transaction signing as well. And the cards that they issue, the 3D Secure thing actually asks you for a CAP respond.
Really?
Would that be better than the systems in the UK, or what's your comment on that?
It appears to be, unless it causes more confusion. You never.
It opens for phishing.
Yes. So we get into these issues all the time. The banks, on the one hand, will tell you never click on a link in an email, yet they'll send you plenty of emails with links in them, right? So they're not educating the customers properly. For instance, they will call the password a PIN, or they will ask you. So if you need to sign up for verified by Visa, and you say, and they'll tell you choose a PIN. What are you going to choose? Chances are you're going to use the PIN on the card, or some people would. These types of confusions just don't help with educating customers against phishing, against these typical attacks.
Short question. I assume that it's possible to lock the cards for PIN entry if you have
these devices? Otherwise, you could just brute force the PIN card?
Yeah, I should have mentioned that there are 3 attempts at the PIN. EMV supports, I think, up to 12 digits for pins, but most people, most deployments use 3. Use 4 digits and 3 attempts.
Any more questions?
A little side note, because you showed those I-10 thingies German banks use, where they tell you what number of PIN they want to have, and then you enter your TAN, not PIN, TAN. Interesting enough, the Citibank had TANs that you could guess. The average distance from one TAN to another was 293. So if you have TANs at home for online banking, make a phase space analysis on it.
They still use it, you say? They're still using that?
No, by now they don't use it anymore. But there's an article on the web, it's called "The Citibank Does Not Play Dice." So there you can read it up in detail.
Fail.
And first they said, no, this is not a problem. And yeah, in the end it came out they used the time, the seconds since the epoch, to generate their pins or TANs. And there's also some, with pins for credit cards, there is a program a few years old from the CCC in Germany. They found out that that the pins they give out with the card, at least the German banks, that it's not evenly distributed in the key space. So there is the chance that a 1 is in your pin is 9 times higher than a 5 or something like that. So there is a program where you can read in the magnetic stripe data, and it will give you the pins ordered by chance that it's the right one. And what also is important with this is that a lot of those ATMs where you enter your pin store the information that you entered a wrong pin on the magnetic strip. So you have 2 tries, then you take out the card, wipe the information on the magnetic strip, and you have another 2 tries. And if you have this program with like the most common pins for your bank account number and card number ordered by quality, one night should be enough to rip off the bank account. But they deny that it's an insecurity, of course.
All right, we have a question in the back.
Personal question. On your personal credit cards, does your magnetic stripe still work?
Yeah, I could have erased it, but as a matter of well, I did check that the ICVV is so. In that program, the bit that I forgot, the bit that I wish you could have seen was about ICVV with the lady from the bank, from Apex, and she announced that from 2008 ICVV should be deployed. So I immediately called my bank. I told them that I lost my card, and so they issued me a new one, and I verified that that ICVV is indeed implemented on my card. And I do have a blog post where I give some recommendations on what you could do. But if I'm traveling and somebody uses the magstripe, when I get home, I change. Well, if they use the magstripe and ask me to put a pin, like they did here in the supermarket, I'll go when I get home. I'm changing the pin. Now So, you know, some of these things are slightly paranoid, but what I also do is I keep very little money accessible on the accounts that are connected to a card. So I keep as much money as I'm willing to lose on those cards, and then I minimize the amount of money that I will have to fight for.
Just a note, at least in Sweden, if they ask for your PIN, just say you don't have it and show them your passport.
Okay, that's good. Then I have to deal with language barriers and stuff like that with the lady at the till. So I don't know.
It's even easier than that, actually. You just say, I don't have the PIN for this card, and then they'll make you sign it instead.
Yeah, because they can't verify it anyway.
No, there's no, I mean, the guy up there with the ponytail, he does it every time with his old MasterCard, so yeah.
American Express.
Oh, sorry, Amex.
All right, any more questions? No? Thank you, Saar.